Good morning. It's great to be here in Munich, one of my favorite cities. So I'm very happy to be here today at the 2010 Nokia Qt Developer Days conference. DreamWorks Animation is, of course, in the movie making business. We make computer-generated or CG movies. But to make our movies and tell stories with stunning imagery, we create a lot of software. So in many ways, we're also a technology company. Today, I'm going to give a high-level overview of how we make our animated CG movies, how and why we make software tools, and where Qt fits into our overall strategy for making world-class films. I'm going to discuss our animation pipeline, which defines the overall workflow and for our artists and the software tools that they use, and we're going to look at also the hardware infrastructure that our software runs upon. I'm going to describe also our software development environment and also discuss the primary motivations that drive our research and development at DreamWorks Animation. And I'm going to wrap up by also looking at how we've got Qt in our organization and what's going to be happening in the coming year. But before we dig in, I wanted to pause and highlight another session today at 1 p.m. that's part of the Qt in Use track. One of our principal engineers and lead UI designers, Gene Reagan, is going to be giving a talk about how he worked to bring Qt into the DreamWorks organization. And he's also going to be talking about the next generation lighting tool that he's been working on for the past couple of years. Gene's a great speaker and an excellent engineer, so I encourage you guys to go see that talk later today at 1. So, since we're going to be talking about how we make movies, I thought that it might be a good idea to start with a short clip from one of our movies that came out earlier this year.
Oh, come on, let me out, please. I need to make my mark.
Oh, you made plenty of marks, all in the wrong places.
Please, 2 minutes. I'll kill a dragon. My life will get infinitely better. I might even get a date.
You can't lift a hammer, you can't swing an axe, you can't even throw one of these.
Okay, fine, but this will throw it for me.
Oh. See, now this right here is what I'm talking about.
But mild calibration issue.
No, Hiccup. If you ever want to get out there to fight dragons, you need to stop all this.
But you just pointed to all of me.
Yes, that's it. Stop being all of you.
Oh,
yes.
You, sir, are playing a dangerous game. Keeping this much raw Vikingness contained. There will be consequences.
I'll take my chances. Sword sharpened now.
Okay, so that was a short clip. I also wanted to talk a little bit about terminology, since we're going to be talking about 3D movies. I wanted to talk about the difference between 3D and stereo 3D. So we've been making 3D movies at DreamWorks Animation for over 15 years, starting with Ants in 1995. And they're called 3D because we model and manipulate the characters and objects in a 3D space in our tools. In 2009, we started releasing all of our movies in stereo 3D, which is often confusingly called just 3D. Now, stereo 3D uses 2 separate images per frame, one for the left eye and one for the right eye. And this provides for a much more immersive 3D experience for the audience. And as you probably can tell if you've gone to a 3D movie recently, we've come a long way since the earlier days of flimsy red and blue plastic glasses. So, what does it take to make an animated film at DreamWorks Animation today? Well, it starts with a great idea, then lots of artistic creativity, lots of effort, and of course, iteration. From start to finish, our films take about 4 years. The first 2 years involves a relatively small team where they focus on the story idea and the artistic concepts and the themes. This is called pre-production. The last 2 years involve a much larger team and lots of computational horsepower, disk space, and network infrastructure. Each film takes about 200 artists and technicians that are dedicated to that one movie. And these days we have about 5 movies in production at any given time. In addition, there are about 250 global software developers at the company that work for all the movies. They develop the tools that are shared, and they build and support them, and that's the basis for all the other specific teams that work on the movies. Recently, we just hit the 2,000 employee mark, so we've been growing quite a bit over the last 2 years. Our movies are 100% computer generated, so that means we render every pixel of every frame. And for a 90-minute movie, that's a lot of data. The data rate for a stereo 3D film is about 100 million pixels per second. And we have over 1,000 terabytes of online disk storage. Each movie takes about 100 terabytes for their working space, and that's used for the final images, but also for lots of digital assets and all the intermediate files that are used through the process of making the film. And we, of course, use a lot of compute power. We have over 20,000 cores collectively on our render farms. And so this essentially puts us into the realm of supercomputing. Pushing the boundaries of animation and special effects means that we're pushing constantly on the boundaries of our compute resources. Here you see a graph of CPU time from the original Shrek to Shrek Forever After, which came out earlier this year, which is a period of about 10 years. And as you can see from the graph, there's been tremendous growth in the rendering time needed for our movies. We write custom software for virtually every phase of the CG movie making process. We have 5 million lines of code that collectively are used to create 8 major GUI applications, and then we have over 2,500 smaller tools that are used to create what we call the animation pipeline. So lots of software. We organize our artists and the software at the studio around what's called the animation pipeline, and there are 3 main phases to the pipeline. The first part is the pre-production part, then production, and then post-production. Together they have roughly 16 different pipeline stages, and each of these stages has a dedicated group of specialized artists and technicians for that area. The work products, or the digital assets, flow from one group to the next, from one pipeline stage to the next. And along the way, there are thousands of different tools that create the assets or modify the assets. They flow through the pipeline, going through various transformations and conditioning until they reach the end of the pipeline where they're fused together to make the final frame. And while this looks like a linear process, in reality, there's a lot of feedback loops, which I didn't show, because as the artwork is reviewed and approved or not approved, it flows back to the front of the pipeline and lots of iterations are made. So during the course of those 2 years in production, there's a lot of different feedback loops between these groups. So I wanted to take a quick, brief look at the few of the stages in the pipeline, just so you get an idea of what it looks like to make a movie. So to start with, the key to a great film is to start with a great story. And at the studio, at any given time, we have lots of different stories that are under development, and the ideas often come from books like Shrek or How to Train Your Dragon. Here we see storyboards being used to show the story to an audience, and that's called pitching this story. The storyboards are drawn by hand, but we've added technology over the years to make it easier and more efficient for the artists to do their drawing. We use what are called Cintiq Tablets, which are essentially flat monitors with integrated digital drawing surfaces on the top. And that allows the artist to use traditional drawing techniques, but they can move a little bit more quickly, and they have features like copy or undo, which can be helpful. Now, while the story is being boarded, other artists and the art directors work on how the film will look. And we call this stage visual development, or VizDev for short. The character design also happens at this stage. Now, here are some Vikings. This is just one of the many paintings that was done in the early days of How to Train Your Dragon, to just get the feel of the movie and capture what the themes might be like. Designers work on the look of the characters, and they also work on how they will act and what their various expressions might be. For How to Train Your Dragon, we realized early on that we would need a lot of long hair and fur-covered clothing for the Vikings, and of course, interchangeable weapons. Now, once the characters are in design, the 3D modeling process begins. We model the characters, but sometimes also their clothing, and each pose takes roughly 2 weeks per character. We also build 3D models for the props or the other objects in the environment. And modeling is one of the areas where we utilize a lot of third-party software. So in particular, most of our modeling is done with tools from Autodesk, in particular Maya, but recently we've also started using Mudbox more and more. The next stage is surfacing, and the artists in the surfacing department work primarily with texture and with color. They create materials that are used to cover the surfaces of the models, and this controls what they're going to look like when light is applied to the surfaces. Human skin in particular requires lots of special surfacing work to be convincing. And until a character is surfaced, you really don't know what it's going to look like. Layout is the stage where the assets are arranged in the scene and where the starting and the ending positions of the characters are established. And layout is also where much of the cinematography is done, which involves setting the camera positions and the camera movement for each of the shots. Here we see a frame in the layout stage on the top, and then that same frame at the bottom after the surfacing and the lighting and the effects have been applied. So we talked about modeling a character, but how do we get the characters to move? Well, rigging is where characters are prepared for animation. Gabber here spent about 6 months getting ready for an animator to move them around on the computer. The rigging artists create the controls that are used by the animator to walk and talk and fight and do all those other Viking things. Here we see some of the 4,000 controls that were needed to fly the Night Fury. And for reference, a typical human character in our movies uses about half that number of controls, or about 2,000. And when you change a control, it causes pieces of geometry in the model to either move or rotate or deform in 3D space. And once the controls have been set up by the riggers, then our animation tools allow the artist to manipulate those controls over a timeline, frame by frame, to control the motion in the scene. So effects, of course, play a very big role in our movies, and it helps to make them very exciting and visually interesting. Fire is a very common effect you see in a lot of films, and if you have fire-breathing dragons, then it's especially important. Besides breathing fire, we also have to set things on fire, like the Viking boats in the background here. And fire is achieved basically through a particle simulator, which drives a fluid simulation. And the color of the fire is varied based on the distance from the emitter or the source of the fire, like the dragon's mouth or the wood that's burning. Smoke and fog are also a combination of particle and fluid systems. Now, creating hair is also a very complex process. It begins modeling the hair as strands of geometry, and then riggers create a style system while the effects department develops a motion simulation. Next, the surfacing artists come in and they apply the various qualities like thickness and the color and the tint. And this process takes many weeks to get just a full head of hair for one character. And as with modeling, the effects department uses a lot of third-party software from Maya. We use it mostly as an effects platform to integrate. And we have hundreds of different custom plugins that we write for Maya to create the effects. Lighting is where all the 3D assets from earlier in the pipeline flow down and become fused together, and it's where really the scene comes to life. Lighting artists literally use hundreds of different lighting elements in each scene, and the artists have to control various parameters such as the position and the direction and the color, intensity, radius, roll-off, dozens and dozens of various parameters for every light to get just the right look. We also use special algorithms for global illumination, which simulates the interaction and reflection of objects within the scene to give it a much more realistic look. Ray tracing is a traditional technique that we use also, but it's very computationally intensive, so we also have some other techniques that we employ. Lighting and rendering together take up about 90% of our overall compute resource usage. So this is obviously a key focus for our research and development. 2 years ago, we embarked on a next-generation lighting and rendering system, and it's our largest software initiative to date. But we'll talk about that in a minute. Now that you've seen a little bit of our animation pipeline, let's turn our focus to the software development process at DreamWorks. I first wanted to start out by talking about where we've invested the most in our software. Our primary authoring applications cover the rigging and the animation and lighting, compositing, and media playback. We have pipeline tools that are the kind of the glue that connect all those other tools and groups together. These apps and tools are built on a number of large core libraries and engines that provide things like data persistence and evaluation of dependency graphs and also the effects simulations. We have geometry and pixel shaders, which are essentially a type of plugin framework for our renderer that allows people to extend and to customize the behavior of the renderer. We also have resource management tools that track and coordinate the flow of work between the groups in the pipeline and also manage our massive rendering farms. And we also keep track of various assets in the pipeline as they flow through with a digital asset management system, which is kind of like a source control system for all the stuff in the pipeline. The software development at DreamWorks happens in many corners, but there are primarily two groups. Developers are either in the technology group and they work globally for the entire studio and for all movies, or they are called production developers and they're assigned to one specific movie at a time. The technology group develops all the core components and libraries in the large-scale applications. And then the production developers on each movie come along and they create special utilities, other plugins, and wrappers that build on top of those core services and apps. And that allows each movie to customize and extend the tools to suit that movie's specific needs. Most of our core libraries and large applications are written in C++. And the pipeline tools are mostly written in Python. We also use Java for our back-end services. We develop the vast majority on and for the Red Hat Linux operating system, although we do a bit of Windows development because some third-party applications have just Windows as their platform, so we have to write plugins there. We use Intel x86-based processors on our HP desktops and HP servers. We do most of our computation with CPUs on these rendering farms, but we do a little bit of GPU development and GPU processing for specialized effects simulations. And we also use OpenGL to get really good 3D graphics performance for our desktop apps. In the earliest days of computer animation, there weren't many tools to choose from. Pacific Data Images, or PDI, became part of DreamWorks in 2000, and they were developing CG software back in the 1980s. So it's understandable then that many animation houses like PDI developed their own tools. But nowadays there are several commercial and open source tools that run the gamut. In fact, there are many smaller production companies out there that essentially run entirely on off-the-shelf software. So why does DreamWorks continue to write so much custom software? Well, let's look at what drives the research and development. Scale. DreamWorks Animation is quite prolific. We produce between 2 and 3 movies a year, which means we have about 5 movies at any given time in production. We also create TV specials and shorts for DVD bonus material, and with that much overlap between the movies, we create more and more data to manage and process. The look of the film is very important. Our filmmakers are quite ambitious, and they're constantly looking for new ways to tell the stories in visually rich and stunning ways. And efficient iteration is key. Artists have many review and approve cycles that they have to go through to get the shots to look just right. And so our software must be very responsive. And ideally, our end goal is to have interactive performance that can really keep pace with the artists. Given these drivers, it's clear why we need to control our own software destiny in many key areas. Performance is paramount. We can always use more performance. And we can focus our attention and optimize our code on just the hardware and the OSs that we use, whereas third-party applications often have to support a wide variety of platforms and OSs and hardware, and that allows us to keep our focus just on what we need. And we can move to a new hardware platform if and when it makes sense. And our tight relationship with HP and Intel really helps us there. Our animation and lighting systems have a dramatic influence on the look of our movies. So they're the main ingredients of what we call our secret sauce. And finally, we can customize and optimize the workflows that give our artists, special capabilities and allow them to work in a kind of a work group kind of environment with centralized asset management. Third-party applications they have to support lots of different customers with lots of different workflows, and so that can kind of dilute the focus for any specific customer. And most third-party tools are not integrated with each other, and they can't really support the hundreds of interconnected users that create films. So we have 3 primary goals for our next-generation tools: interactive animation, lighting multiple shots in parallel, and increased rendering performance. And to achieve these ends, we're focusing on several key areas. First, cores aren't getting any faster, so we're going to have to multi-thread our software to take advantage of the latest multi-core hardware architectures. We're going to put the asset management inside of our tools, and that really simplifies the life for our artists because they're not switching back and forth between different tools. They can be right inside of the tool. And artists work better and faster when they keep their focus on the art that they're working on. So we're building powerful new OpenGL 3D viewers that allow artists to directly manipulate the objects that they're creating rather than working indirectly through property sheets or spreadsheets. And to build these new applications, we really need a solid foundation. So we're building larger and more multifunction applications with reusable components and subsystems, and then we extend and customize through a new plugin architecture from our app framework. We don't write all of our own software tools, and we want really the best of all worlds. We use Maya extensively for modeling and effects, as we've talked about, and much of our post-processing pipeline is based on third-party tools. But make versus buy isn't just about the tools that the artists use, it's also about the tools that the developers use. And one of the biggest challenges that we've faced over the last few years is that our graphical user interfaces were built on an outdated, difficult to maintain proprietary application framework that we developed many, many years ago. And over time, the cost of supporting and improving that custom framework became way too great. Increasingly, we would conceive of new workflows or new UI ideas that we wanted to implement, only to realize that it would be impractical to do with our legacy framework. So we considered several different options, looked at many different alternatives, and including a complete overhaul of our existing framework. But in the end, the choice was clear. We needed to adopt Qt. So why did we choose Qt? Of course, Qt is known to be very stable and feature-rich and mature. And in addition to those compelling features, we also chose it because it had Python support via PyQt. And we've invested heavily in our Python tools, so this was key. It has a commercial license option. And for DreamWorks, when we have so much riding on third-party tools, we like to have a pay-for support model, similar to what we do with Red Hat. And there's excellent documentation and training, which has been key to ramp up the hundreds of developers that we have at our company. Leveraging the Qt framework also frees up development resources, and that allows us to focus on our key differentiators, which are the high-level user interactions and workflows, and our low-level performance of our engines and our renderer. And overall, Qt has allowed us to accelerate our pace of development. Bringing Qt in-house for new application development was fairly straightforward because we could use it pretty much right out of the box. But our biggest challenge was our massive legacy code base. And we really wanted seamless integration. We wanted to be able to use new Qt functionality with our old apps. But we didn't want to break any of our existing apps, and we didn't want to do a brute force port. So this turned out to be one of our biggest challenges, and later in the Qt in use talk at 1 p.m., Gene's going to go into a lot of the technical details of how he pulled that off. He was the major driving force behind that. So what has our experience been so far? Well, over the last 2 years, we've made great strides with Qt. Our developers have ramped up quickly, and Qt is in wide use across DreamWorks. We're using Qt and PyQt essentially for all new UI development at the studio. And looking forward, next year we're going to be delivering our 2 major new applications built entirely on the Qt platform, our next generation animation system and our next generation lighting tool. And we still have lots of integration work and testing and tuning work to do, but we've built all the major GUI subsystems, and so far things are looking really, really good. So we're very happy. And it's clear that we could not have made this type of progress without Qt. It's really great to know that we've built our next generation tools, which are going to serve us for hopefully 10 plus years on such a solid foundation. So to those of you who are considering Qt for your own products or services, I encourage you to take the next step and give it a test drive, and I think you're going to be amazed, because we certainly were. So I wanted to close today with a trailer from our soon-to-be released movie called Megamind, and I wanted to thank you for your time today and say please enjoy the rest of the conference.
I've always believed that destiny chooses our path in life.
Here is your sidekick.
And here is your pinky. You are destined for...
Destined for what? I didn't quite hear that last part.
They came to our world together. But they were destined
Our baby can fly.
Yes, nothing but the best for you, darling.
To take different paths.
Can we keep it?
One would be cheered,
Happy Metro Man Day, Metro City.
I love you, Metro Man! And I love you, random citizen.
while the other
Table for two.
was feared.
What? What?
But on November 5th,
A new threat has come to Metro City,
Consider yourselves under new management.
and Metro Man is nowhere to be found.
He'll destroy the whole city.
I'm sorry. I'm finally free to get in touch with my true power. Making awesome music.
You're kidding, right?
when the world needs a hero,
You need to be that guy.
Well, this is a strange turn of events.
he will answer the call.
Hello?
It's hello.
Oh. Hello? Like that?
And the superhero movie
Just a few alterations, and I will be done with your cape. I'm calling it the Black Mamba.
will never be the same.
Let the showdown begin!
Will Ferrell,
Where did you park the invisible car?
Tina Fey,
What's the plan?
It mostly involves not dying.
That's a good plan. I like that plan.
Jonah Hill,
Quick, the spray.
All out.
Well, use the forget-me stick.
Oh, right.
I think it's working.
and Brad Pitt.
Check this out.
I have eyes that can see right through lead.
Huh?
DreamWorks Megamind in 3D.
Do you have your disguise?
What?
Oh, you look fantastic.